Hey guys, welcome back to my channel. And our today's topic is going to be on ACL, that is also known as access control list. So this is going to be ACL part 2, right? Because we have already seen ACL standard in my previous video. So this is going to be ACL extended, right? So guys, let's just do the recap first. What exactly the ACL is? If we go with the definition of the ACL, so ACL is a set of rules that deny or permit the traffic passing through the router. Okay. So ACL is also called a layer 3 security, and we also call it as a packet filtering firewall. Right? So when we talk about the range of the ACL, in standard ACL we have the range of 1 to 99 comes under the standard ACL, and 100 to 199 is the range for extended ACL. If we talk about what all things can be done under the standard ACL, so in the case of standard ACL, we can block a host, we can block a subnet, and we can block a network, right? But in the case of standard ACL, all services are going to be blocked. Why it is going to block all the services? Because the decision is going to be based on the source IP address, right? Because in the case of standard ACL, we always go with the source IP address. So once we are going to configure the ACL, we are going to mention the IP address of that device from where the services are going to be blocked. So once it will reach to the router, so router is going to block it there and then. So that is what it is going to block all the services, right? Now we are going to talk about extended ACL. So if we go with the definition is going to be same for the extended also. So the only difference is that between the standard and the extended is because it is also going to be used for blocking the host, blocking the subnet, blocking the network. But in the case of this extended ACL, we are going to block selected services, right? And when we talk about the range of this extended ACL, as I have told you in the beginning, so the range of this extended ACL would be 100 to 199, right? So we are just going to see it practically. So let's get into the practical now. So let's see it practically how we have to configure this extended ACL. For that, let me just open my packet tracer, and then we will see how we can perform the practical on this extended ACL. So I'm just opening my packet tracer, and I have to create the hierarchy. So guys, I would also like to mention one thing here is that, like, whenever we are just going to block one particular network, right? So we are going to use the wildcard mask, right? So let me just create my network. I'm going to take this router. This is going to be for my first network, and this is going to be my second network. And let me just take the switch also, which is going to be used for connecting my end devices, right? Why we are taking the switch is because the router is having limited ports. So if we have multiple end devices, so because of that we make use of the switch, because switch is having multiple ports. So this is connected, this is also connected, and let me just make the connection between the router to router. Right, this is also done. Let me just make it more clear to you, and I'm just going to take some PCs here. Let's say this is PC1 and this is PC2, I guess, and I'm going to take some devices also. Right, so let me just make the connection. So connection is created. Right, so let me just assign the IP address. Let's say this side I'm using a network of 172.16.1. network, and on the other side I'm going to use it as 192.168.2.0. right, so here I'm going to take it as 172.16.1.2. let's say this is 3, and on this side I'm going to take it as 192.168.1.2, and this is going to be 3. One 192.168.2.3. sorry, I have to make it 2, but by mistake I made it 1, so I'll make it 2. 2.2 and 2.3. So I hope the topology is clear to you. Right, so what we are going to do, we are just objective. Let me just write the objective. Right, 172.16.1.2 should not ping 192.168.2.3. this is our first objective, and our second objective is 172.16.1.3 should not open website on 192.168.2.2. right, so let me just take the IP here also, 10.0.0.1, because we have to do the routing between these routers, then only we can start communicating to each other. And now I'm going to take it as 2, this is 1, right, so let me just, 1 second guys. So guys, let me just configure my router also. So I'm going to my CLI. Right, so we are having 2 interfaces for my router. So if we are not able to see the interface, so what we can do is, we are not able to see the interfaces, we can go to the option preferences, and here is the option called always show port labels in the logical workspace. We just need to enable this, and then we will start seeing our interface. Like this is FA0/1 and this is FA0/0. right? Let me just open the CLI, and on this FA0/1 interface FA0/1 IP address 10.0.0.1 255.0.0.0 no shut. Interface FA0/0 IP address 172.16.1.1 255.255.0.0 no shut. Let me just write the configuration also, so that it will be saved, because in any case if my router is getting rebooted, then I need not to write the entire command again and again, right? So this and this has been configured successfully. Let me just go to my second router. So this is my second router. I'll again go to the CLI. I will enable it, right? So similarly, I have to configure both my interfaces. I have to set the IPs on my interfaces. So here also I have this FA0/1 also, interface FA0/1 IP address 10.0.0.2 255.0.0.0 and no shut is to make the port up. So this port is also in the upstate. Now I will go to my FA0/0 interface FA0/0 and the IP address 192.168.2.1 255.255.255.0 no shut. So guys, as you can see, this all our interfaces are in the upstate now. So if I'll show you, if you want to see the if you want to confirm that whether your interface has been assigned the IP addresses or not, so what you can do is, on the global configuration mode, you can make use of this command, do show IP interface brief. So as you can see this, on the fast Ethernet 0/0 we could successfully assign 0/0. We have successfully assigned 192.168.2.1, right? And on fast Ethernet 0/1 we have assigned 10.0.0.2. So guys, don't get confused with this value 192.168.2.0 or 1.0, because this is the house of IP. So it denotes a network, right? But as far as the IP of the devices are concerned, so it will always start with 1. So that is what we have taken this interface value as 172.16.1.1, and similarly here also we have taken the value as 192.168.2.1. So this is just for your clarification basically. So both my devices are in the upstate. Let me just write the configuration. Configuration has already been written. Now if I want to ping my router 1 to router 2, right? So let me just save it here. Host name, one second, here is host name. Let's say this is my R1. Sorry, this is my R2. Host name R2, right? And the other one, let me make it R1. Let me just go to the CLI, host name R1, because this would be more clear to you, right? Now as you can see this, I am on this R1, and if I want to ping my this device R2, so what I'll do, I'll make use of do ping 10.0.0.2. So guys, as you can see this we can successfully ping this. I'll re-ping it again, right? You can see this success rate is 100%. When we are getting the success rate 100%, it means so the communication between both the devices are in the upstate, and we can see that 5 packets have been sent and received. So this is how you can come to know whether the communication is happening or not. So let me just try. Now if I will try to ping from this device to this device, it will not ping now because we have not done the IP routing yet. So before that, let me just assign the IP addresses. One 172.16.1.1, right? Let me just close it. One 172.16.1.3, 172.16.1.1, right? Similarly, let me just assign the IP address to my second network also. So IP for this is 192.168.2.2, 192.168.2.1. Let me close it. Now I am going to assign the IP address to my server, right? I'll go to the desktop, IP configuration, and here I am going to choose 192.168.2.3, and the default gateway would be 192.168.2.1, right? So guys, as you can see this, like we have successfully assigned the IP address to the end devices also. Now what I'm going to do, I'm just going to ping from my 172.16.1.2 to this IP, and this will not happen because we have not yet done the IP routing between these devices, because unless and until routing is not there, it is not going to ping to each other, right? But I just wanted to show you. I'll just ping this device 192.168.2.2. Let's see. So guys, you can see this. We are not getting any reply from the other device. It is showing RTO, request timed out. So the connection is not happening because of the routing only. Let me just try once more time so that it will be confirmed to you. The connection has not been happened yet. So it is not pinging. You can clearly see this. Now we are just going to do the routing so that the communication between two different networks will start happening, right? So let me just go to my first router, and today we are just going to make use of this one of the routing protocol called EIGRP, right? So I am on my, one second guys, yes, this is done. I am on my R1, right? So I am going to configure router EIGRP and the autonomous number, let's say 51. We can take any number, right? So we are just going to broadcast our network, like we are just going to advertise our network. Basically, this is the right word. We are just going to advertise the network. So how we can advertise the network? With the help of this network command, right? So on this interface, on this router interface, we are having two different networks. So we just need to advertise ourselves. Rest of the work will be done by this EIGRP only. So what I'm going to do, I'm just going to put the network address here, right? Enter. Similarly, I'm just going to make use of 10.0.0.0. Guys, you must observe one thing is here is that, like I'm not giving the IP address here, I'm giving the house of IP address, that is the network address, right? So that is what I have mentioned, like 172.16.1.0. so we have to give the network address here. Right? So this is done. So if I show you, so we can see this. Now we have the network of 172.16.0.0 and 10.0.0.0, right? We have already advertised ourselves. Now let me just go to my other router, and same thing I am going to do with this router also, because we have to advertise ourselves, right? So again, router EIGRP 51. Guys, one thing here is to be noted is that, like, when we are configuring this EIGRP, and we have to give the one autonomous number, right, which I am giving it as 51. So this autonomous number should be same on both the devices. If you are going to use a different autonomous number here, then it is not going to establish the connection between two different networks, right? Network. I hope this is clear to you. So I'm just going to advertise the network on the router 2 also. And one more network we have is 110.0.0.0. I'll just show you as you see this. So I'll advertise this also, right? So adjacency has been created. So let me just run this command. So as you can see this, guys, we have the root for this 172.16.0.0 that is shown by D, right? So basically whenever we get this alphabet D, so it indicates that this is a EIGRP root, because EIGRP follows this dual algorithm, diffusing update algorithm. So you can understand this way. D is for EIGRP, right? Root has been transferred from one router to the other router. So let us try to ping now, and we will check. So I will try to ping 192.168.2.3. Let us wait now, and then we will check whether we are able to ping it or not. If we are not able to get the pinging, then we will troubleshoot the network. So we are not getting the reply. Okay, now we have to troubleshoot this network, right? So let me just check this. Let me just try once more time. .2.3. No, it's not pinging. Good. So now you will be getting an opportunity to like see how what could be the issue, why it is not pinging, because we have done the routing on both the ends, but still it is not pinging. So first of all, what we have to check, like whether the IP has been assigned on the router or not. That can be one of the issue. So let me just close this. So first of all, what we are going to do, we are just going to check whether the IP has been assigned on these interfaces or not. So we will start with this router only. I'll open my router, do show IP interface brief. So as you can see, this IP has been successfully assigned 172.16.1.1, right, and 10.0.0.1, that is there. Do show IP route. So we have the route for 2 network also, so it should work. So let me just check whether the IP has been assigned or not. 2.3 is the IP, right? .1 is the gateway. Okay, let me just go to this router also, and we will check the IP configuration. Do show IP interface brief 2.1. So this is for 0/0, this is also correct, and 10.0.02, that is also correct. Okay, let me just go to this route, this machine. Guys, you can see this, there is one little mistake. So instead of this 16, I have mentioned that 18, 168. So this is the only mistake, otherwise rest of the things are the same. So I have just corrected this mistake, and now it should ping to that particular device. Ping 192.168.2.3. So let's wait and we will check whether we are able to get the connection or not. If not, we will troubleshoot further. Right guys, as you can see this, we are successfully able to ping our network. So guys, one thing I would like to mention here is that like I am not doing anything in advance. So whatever I am doing just in front of you, so that if we are making any kind of mistakes, either in the either at the command side or something else, then you are going to see it yourself, like what could be the issue, what could be the possible solution to fix such kind of issues. Those things you are going to see, right? So my videos are not pre-recorded, so whatever I am doing in front of you only. Now we are successfully able to make the connection between both the networks. So let me just try to ping from this network, this machine to other machine, right? Just to confirm that the communication is properly happening. So let me just try to ping. One second guys. This time I am just going to ping my laptop 192.168.2.2, this one I am talking about, and we will check we are able to get the connection or not. So guys, we are able to get the ping response from that machine, right? So up till now we are able to do the communication between two different networks, right? Now we are just going to talk about this ACL extended, right? So what we are going to do, we are just going on our router. So first thing I would like to show, I would like to tell you here is that like when we talk about the extended ACL, so we apply the extended ACL, right, to the source. In standard ACL we used to apply the ACL near to the destination, but in the case of this extended ACL we apply the extended ACL near to the source. So our source is in this case this IP address 172.16.1.2. So what we are going to do, we are just going to apply the ACL on my FA0/1, right? So let me just go to my router, right, and here we are going to apply the access list, and we have to give one number because as you know that like for the standard access list the range is like 1 to 99 and 100 to 199 is for extended ACL, right? So I'm just going to take 101, and here what I'm going to do, I'm going to deny, right, what ICMP, right? Basically, as I told you, as per my objective, like my 172.16.1.2 should not ping to 192.168.1.2.3, right? So basically what we are going to do, we are just going to apply our ACL, and this is how we apply the ACL: access list space the number of the ACL, right, whatever number we are going to take, because based on this particular number system is going to decide whether this is a standard ACL or an extended ACL, right? So that is what we have taken this 101, because 101 comes under this extended ACL only. You can take any other number if you want. And what we are going to do, we are either we are going to permit it or we are going to deny this. So we are going to deny this, right? And which protocol? The ICMP protocol. And what is the address? Source address 172.16.1 right. So basically we need to check whether we have to deny the entire traffic or like the traffic for this host only, right? So we are just going to block the entire traffic for this, right? None of the device should be able to ping it, right? Right, guys. So basically if we want to block the entire traffic for this particular network, then we will take it like this 172.16.1.0, or if we are just going to block it for one particular device, then what we need to do, we will have to make use of host, right? We will make it use of host. One second, guys. Yeah, guys, sorry. So what exactly we are going to do here is that, like, we are going to create the access list, and we have taken the access list number as 101. We are going to deny the traffic, right, ICMP traffic, right, for the host, because we are going to block the ICMP traffic for one particular device, right? And the IP address of that device is 172.16.1.2, right? And as I told you in the beginning, in the case of this network, right, in the case of network, we have to in the case of network, we have to use this basically a wildcard mask, I mean to say, right? But in this case, this wildcard mask is not required, because we are not going to talk about a network, right? Then we are just going to block the traffic from 172.16.1.2 to host 192.168.2.3, right? And here we also have to make use of one command equals, right? So we will have to like give the port number, right? As we know that, like for this one second, if we want to block the traffic for this HTTP, right? So for HTTP, we the port number is 80, right? And when we talk about let's say we want to block the traffic for this FTP, right? For FTP we use this 21, right? And for this ICMP we have to put the port number, right? Which port number it is, so that we will put. One second, guys. So let me just check the ICMP port number so that it will be clear to you. I'll just show you. For HTTP, port number is 80. As you can see this, for HTTP port number is 80. And if we talk about the port number for this FTP, so there are two port number, 20 and 21, as you can see this here, right? And when we talk about this ICMP, right, one second, port number for ICMP, right? Firewall rules for ICMP TCP UDP port number 7, right? Or what is the port number for ICMP? ICMP has no concept of port as TCP and UDP do. So guys, this ICMP is not having any port concept. We don't use any port number, right? So we can straight away say ICMP. No need to assign the port numbers. So let us simply say enter. So this access list has been created. Show access list. 1 second guys. Show access list. So as you can see, this access list has been created, and by default it has taken the number as 10, right? Now what we are going to do, because by default it is going to like block everything, like whenever we create the access list, by default is deny only, right? So we just need to configure terminal. 1 second guys. Access list. 1 second, which number we have taken? 151, right? Let me just see this. 101 we have taken. 101, right? So we have to permit. Earlier we have said denied, like as you can see here, access list 101 deny ICMP, right? So we are going to say permit any. So guys, why we are using this any? Because as you know that in the extended ACL, right, we talked about the source address as well as the destination address, right? So what this command does, so whenever we are writing this command as access list 101 permit करो any, मतलब ये जो हमने ब्लॉक किया है, other than this rest should be allowed. If we will not put this command, then it is not going to work for us. 1 second. 1 second. So we have to configure terminal. Configure terminal enable हो गया. 1 second guys. So router EIGRP. 1 second. Enable configure terminal, right? So we are in the configuration mode, and show IP EIGRP do show IP EIGRP do show IP route. So these are the routes we have. 1 second guys, just give me a moment, let me just check it. Access list 101, right? So that we have already enabled access list permit ICMP any. Guys, can you see this? Earlier there was one mistake from my side. I forgot to use this ICMP any, and I was using permit any. That is what it was giving me the error. Now this command has been successfully executed. So this is how we have to troubleshoot basically, right? This command has been successfully executed. Let me just save the configuration. So so my configuration is also saved, right? So let me just try to ping from this device to that device, and then we will check. One second, guys. Let me just put it here. Ping 192.168.2.3. So it is pinging. One second. So it means ACL has not been applied successfully. Just a second. One second, guys. Let's check now. We have applied this ACL on this interface. Show. One second. Show access list. So we are just going to deny the traffic ICMP host 172.168.1.2 to 192.168.2.3, and then 20 ICMP any. One second. And 2.168.2.3. So it is pinging. One second, I just need to check why it is pinging. Just give me a moment, please. So guys, so we have basically created the access list, right? Because if I show you, show running config. One second. Show running config. Right? If I show you the configuration of this, so we have just created the access list, but we have not yet, you see this access list 101 deny ICMP host this address to this address, right? And in the second command what we are saying is like accept this, permit any, right? Now we have to apply this ACL on this interface, right? That we have not yet done. So let me just go to my interface FA0/1, right? IP access group, right? And 101, right? IP access group 101, and we have to tell like whether it is inbound or outbound. So guys, I would like to tell you one thing is that like when I am going from here to there, so this route is going to be inbound, this is inbound, and when we are going out from this interface, so this is inbound, this is going to be outbound, right? So this inbound outbound it is talking about. So here I have to say out, right? So configuration is saved now. So let me just try to do the same thing again. Let me just try to ping it. One second, guys. Ping 192.168.2.3. So guys, as you can see, this ACL has been successfully applied, right? Because we are not able to ping it. We are not able to ping 192.168.2.3, as you can see this. And if I'll try to ping my another device, that will start pinging, because I have created one more ACL and there I have defined that accept this, allow any, permit any, I mean to say. So I'll try to ping this laptop, ping 192.168.2.2, So guys, you can see that like we are successfully able to ping the other device, but we are not able to ping my server, right? So in the same way we can create the ACL for the HTTP also, right? If you want, I can just show you now how we can create it. So same thing we are going to do it here again. So let me just put it here, 1 second guys, or let it be here only. 1 second, I'm just putting it here so that you can see the IP clearly. 1 second, right, this is fine now, right? So we are going to create the access list 101, right? Deny. Now here we have to tell like which traffic we want to deny, right? So this time we are talking about the HTTP port, so we will say deny, and because HTTP comes under this TCP only, so we will say TCP, and again we have to give the host address, right, for which host we want to deny the HTTP traffic, right? So for this machine we are just going to block this, right, host 172.16.1.3, then again for which machine, host 192.168.2.2, right? And here we are going to make use of equals. Equals means here we have to define the port number, because as I told you in the beginning, we have the port number for HTTP is 80, right? So we are just simply telling the system that you have to block this website for this particular host, right? So I will enter, right? This access list has been created. So we have to again, if I say to show access list, right? So earlier, as you can see this, like we have like deny and permit ICMP. So similarly, same thing we have to do it for this HTTP traffic also. 101 permit. 1 second guys, access list 101 permit, right, TCP, right, any, right, enter. Let me just write it, and we will see whether we are able to successfully block this machine to access this website, right? So what we are going to do, we are just going to double click on this, and we are going into the web browser, and here we are going to type the address of that server 192.168.2.2. As you can see this, it has been blocked, right? If I just try to open the website of the other device 3, so we are able to open the website, right? So guys, this was all about this standard ACL, this was all about this extended ACL, in which we have learned that like we can block certain services, and we can block one particular host, we can block one particular like network. All those things can be done in the extended ACL. So I hope you guys are clear on this extended ACL also, and if you have any doubt or if you want any clarification, then please feel free to ping me, and I will try to answer your queries also. And if your queries are still not getting resolved by watching the video, you can just ping me, and we will have one-to-one call and I will try to resolve your queries. So thank you very much for watching my video, and if you really like the video, so please subscribe to my channel, and also give some valuable comment, so that it would be like so that I'll come to know like what all things are you learning from my material or not. So whatever content I'm just going to deliver it here, is it like giving you some boost in your career or not, right? So thank you very much once again, and hope to see you soon. Thank you.